As I mentioned before, the normal distribution accounts for data items meaning 100% of the scores. This means that we can use 1217 to find the percentage data items that are also greater than a normal distribution. And so if we get a z-score and we want to find out what are greater than, what we have to do is we have to subtract the percent we find in the table from 100 to find the percentage of data items that are greater than the item in question. So this technique, we're going to use phrases such as greater than and greater than or equal to as equivalent. So that's kind of a key thing there. And so that's what we'll be doing for this next example, which says that the female adult heights in North America are approximately normally distributed with a mean of 65 inches and a standard deviation of 3.5 inches. What percentage of North American females have heights that exceed 69.9 inches? All right, so what we need to do is we need to find our z-score, and so hopefully it'll let me do that, maybe eventually. So z is equal to, well, 69.9 minus my average, which is 65, or the mean, divided by the standard deviation of 3.5. So if I plug that into my calculator, I get, again, I'm going to put parentheses, so that was 69.9 minus 65 divided by, and that was the 3.5, and we get 1.4. All right, so my z-score is 1.4. Now I want it to exceed that, and so 1.4 gives me 91.92, and so that means this corresponds to 91.92% or less. So to be more, I'm going to take 100 minus 91.92, and that's going to give me the score that's going to be greater than. So that's going to be what, 8.08% is going to be greater than the 69.9 inches. So I had to take the total minus what I found here, and that gives me the actual value that's going to be greater than the 69.9 inches. Okay. All right, so what we're going to do is now we've seen that table we can use to find percentage of data items that are less than or greater than any data item, but it also can find data items between 2 points. So what we're going to do is we're going to look between here and here maybe. Okay, so because the percentile for each item is the percentage of data items less than the given item, what we can do is the percentage of data between two items is found by subtracting the lesser percent from the greater percent. Okay, and so basically, this is item 2, and we want to find between item 2 and item 1. Well, we're going to say, okay, well, item 1 gives us this value, and we find the z-score. Item 2 gives us the whole thing. So if we take the whole thing minus that, what we're left with is what's in here. Okay, and so that's how we're going to solve the next problem. Well, actually, we're going to use this to kind of talk about it first, and then we'll solve the next problem. But finding the percentage of data items between two given things. First, like we talked about, you find the z-score for each of them. And then we find the percentile corresponding to each z-score, and then we subtract the lesser from the greater. So that's really what we're doing. So again, it's not anything different. We still have to find the z-scores. We still have to get our number corresponding to the z-score from the table. The only difference is now we take the larger minus the smaller to get that percent that's between them. Okay. So with that said, the distribution for the life of refrigerators is approximately normal with a mean of 14 years and a standard deviation of 2.5 years. What is the percentage of refrigerators that have lives between 11 and 18? All right, so Z is going to be what for 11? Well, it's going to be 11 minus 14 over 2.5. So that's going to give us, if we get our, well, actually, let's do two things here. Before we go look at the calculator, let's also look at the other one. So the other one is going to be Z equals 18 minus 14 over 2.5. So now we can get two calculations all at the same time, and then we can write those down and find our z-scores. All right, so the first one was 11 minus 14 divided by 2.5. So that's a negative 1.2. And the other one was 18 minus 14 divided by 2.5. And that gives us a 1.6. So those are my two values I need to look up in the table. And that was a negative 1.2, and that was a 1.6. So now I'm going to look at the percentiles in the table. Negative 1.2 is over here. So it's going to be 11.51. And the 1.6, that's going to be 94.52. So that was 11.51%. This was 94.52%. And now I'm going to find the difference. I'm going to take the larger minus the smaller. And when I do that, I get 83.01%. So that's going to be the percentage of refrigerators with lives between 11 years and 18 years. Okay, so that's kind of a nice application of how we can use z-scores to find a range between two things and get our value out as far as what the percentage will be. All right, so let's stop there and we'll come back for more.